presents myself, Henna, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of system of linear equations and matrices, right? So firstly, let us recall what are eigenvalues and eigenvectors. Okay, so let A be a square matrix of order n if there exists a non-zero column matrix X and a scalar lambda such that Ax is equals to lambda x, then lambda is called eigenvalue of A, and a non-zero column matrix X is called eigenvector corresponding to lambda. Now we have studied characteristic equations, right, for 2 cross 2 and 3 cross 3 matrices. So the characteristic equation for 2 cross 2 matrix is lambda square minus s1 lambda plus s2 is equals to 0, where s1 is sum of principal diagonal elements, right? That means trace of A. S2 is determinant of A. So using this equation, we will find our eigenvalues. Next, the characteristic equation for 3 cross 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 equals to 0, where s1 is the same, that is trace of A, right? S2, this is very important, is the sum of minors, right, of principal diagonal elements. And our S3 is what? Determinant of A. Okay? And the equation to find our eigenvectors is A minus lambda Ix equals to 0. So using this equation, we will find our eigenvectors. Okay, so now let's move on to an example. Here we have to find the eigenvalues and corresponding eigenvectors of the following matrix A, which is equals to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Okay, so let's start with the solution. So here the characteristic equation of a square matrix of order 3 will be given by lambda cube minus s1 lambda square plus s2 lambda minus s3 equals to 0. So using this, we will find our eigenvalues, right? So let us start finding the value of our s1. So s1 is equals to what? Sum of principal diagonal elements of the matrix A, or it is also known as what? Trace of the given matrix. So here the principal diagonal elements are what? 8, 7 and 3. So add these three numbers, so you will get answer as 80, right? Next, S2 is equal to sum of minors of principal diagonal elements of A. That is, you have to find the minors of 8, 7 and 3, right? So let us find the minor of 8. So hide this row and column, right? So the minor will be 7 minus 4 minus 4 3, right? Similarly, we will find the minor of 7. So hide the corresponding row and column. So the minor will be 8 2 2 3, plus lastly find the minor of 3. So hide that corresponding row and column. So the minor will be equals to what? 8 minus 6 7. Now find the determinant of all the three minors, right? So answer will be 5 plus 20 plus 20. On simplifying, you will get S2 as what? 45, right? Now we have to find S3, which is equals to determinant of A. So find the determinant of the matrix A. So keep it as it is. Now 7 into 3 will be 21 minus 4 into 4 16, right? And minus minus plus. So here it will be plus 16 plus 6 times minus 18 plus 8 plus 2 times 24 minus 14. Now simplify this. So you will get answer of our S3 as what? 0. Now we'll put the values of S1, S2, S3 in our characteristic equation. So finally our characteristic equation will become lambda cube minus S1 is 18. So minus 18 lambda square plus 45 lambda. Our value of S3 is 0, right? So here nothing will come, is equals to 0. Now we have to simplify this, that is we have to find the factors and find the value of lambda. So take out lambda common from this equation. So it will be equals to lambda times lambda square minus 18 lambda plus 45 equals to 0. On further factorization you will get lambda into lambda minus 3 into lambda minus 15 equals to 0. Right? The factors of 45 are 15 into 3 and the sign of the middle term is minus, right? So the factors will be what? Lambda minus 3 and lambda minus 15. Okay? So finally the values of lambda will be equals to what? 0, 3 and 15. So these are our eigenvalues. Now corresponding to each eigenvalue we have to find eigenvectors. So let us start finding the eigenvectors corresponding to the eigenvalue lambda is equals to 0. So putting lambda is equals to 0 in our equation a minus lambda ix equals to 0. What we will get? A times x is equals to 0 because the value of lambda is 0. Right? Now our matrix A is this. Okay? So finally now form the linear system from this. So the equations will be what? 8x minus 6y plus 2z equals to 0, minus 6x plus 7y minus 4z equals to 0, and the last equation will be 2x minus 4y plus 3z equals to 0. Now we will consider only first two equations, right? So taking first two equations and taking out 2 common from the first equation and minus common from the second equation, we will get 4x minus 3y plus z equals to 0 and 6x minus 7y plus 4z equals to 0. Okay? So now using our Cramer's rule, what we will do? We will write x upon the coefficients of y and z. So it will be minus 3, 1, minus 7, 4. Now this is equals to minus y upon. Now hide the coefficients of y and write the coefficients of x and z. And they are 4, 1, 6, 4. Finally write z upon. Hide the coefficients of z and write the coefficients of x and y. So you will get 4, minus 3, 6 and minus 7, right? Now we just have to simplify these determinants, these three determinants. So what you will get? X upon minus 5 is equals to minus y upon 10 is equals to z upon minus 10. So now taking out 5 common, what we will get? X upon minus 1 is equals to y upon minus 2 is equals to z upon minus 2 is equal to assume it as t1, because this type of system will always have infinite solutions, right? So finally our eigenvector will be equals to minus t1, minus 2t1, minus 2t1. Now take out t1 common. So it will be equals to minus 1, minus 2, minus 2, which can be written as t1 x1, where our x1 is the eigenvector corresponding to the eigenvalue lambda is equals to 0. Okay. Now let us find the eigenvector corresponding to lambda is equals to 3. So now our equation is what? A minus lambda ix equals to 0. Okay. Now put the value of lambda as 3. So you will get A minus 3 ix is equals to 0, right? So what you have to do? Put A first. That is 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3, right? Minus 3i means 1 0 0 0 1 0 0 0 1. Now you have to subtract these matrices. Means the only change will come in the principal diagonal elements, because all the elements above and below it are 0, right? So finally just make a change in the diagonal elements. So 8 minus 3 will give us answer 5. Next, 7 minus 3 will give us answer 4 and 3 minus 3 will give us answer as 0. Okay. Now we have to form the linear system from this. So the first equation will be 5x minus 6y plus 2z equals to 0. The second equation will be minus 6x plus 4y minus 4z equals to 0. And lastly, the equation will be 2x minus 4y plus 0z equals to 0. Okay, again we will consider the first two equations, right? And from the second equation, we will take out minus 2 common. So what we will get? 3x minus 2y plus 2z equals to 0. Now using these two equations and applying our Cramer's rule, what we will get? X upon, write the coefficients of y and z, minus 6, 2, minus 2, 2 is equals to minus y upon 5, 2, 3, 2 and lastly z upon 5 minus 6, 3 minus 2. Now solve all these three determinants. So what you will get? X upon minus 8 is equals to minus 5 upon 4 is equals to z upon 8. Now we will take out 4 common. So what you will get? Minus 2, minus 1 and 2 and assume it as T2. Right? So finally our eigenvector x will be equals to minus 2t2 minus t2 and 2t2. Now take out t2 common. So what you will get? Minus 2, minus 1 and 2. Assume this as our x2. Right? So you will get t2 x2. Now our x2 is known as the eigenvector corresponding to lambda is equals to 3. Okay? Now we will find the eigenvector corresponding to lambda is equals to 50. Again write your equation, that is a minus lambda ix is equals to 0. Right? Now on putting the value of lambda is 15, you will get a minus 15 ix is equals to 0. Again write the value of the matrix, that is 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Now we have to subtract minus 15 times the identity matrix, right? That is 1 0 0 0 1 0 0 0 1. Again the change will come only in the principal diagonal elements. So just subtract minus 15 from these three elements. So what you will get? 8 minus 15, that will give us minus 7. 7 minus 15 will give us answer minus 8. And 3 minus 15 will give us answer minus 12. Right? Now again form the linear system from this. So you will get minus 7x minus 6y plus 2z equals to 0. The next equation will be minus 6x minus 8y minus 4z equals to 0. And the last equation will be 2x minus 4y minus 12z equals to 0. Right? Again we will consider the first two equations and take out minus 2 common, right, from the second equation. So what we will get? 3x plus 4y plus 2z equals to 0. Okay. Now we will apply our Cramer's rule. Okay. So what we will get? X upon minus 6 2 4 2 is equals to minus y upon minus 7 2 3 2 and z upon minus 7 minus 6 3 and 4. Again solve these three determinants. So what you will get? X upon minus 20 minus y upon minus 20 and z upon minus 10. So now we will take out what common? Minus 10 common, right? So you will get 2 minus 2 and 1. Assume this as T3, right? So finally our x will be equals to 2t3 minus 2t3 and t3. Take out t3 common. So what you will get? 2 minus 2 and 1. Right? Assume this as x3. So you will get t3 x3. Where our x3 is the eigenvector corresponding to lambda is equals to 50. Okay? So in today's session we have studied to find eigenvalues and eigenvectors. Right? We have used the characteristic equation of order 2 cross 2 or order 3 cross 3. So it is lambda square minus s1 lambda plus s2 is equals to 0. And for this the equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equals to 0. Now after finding the values of lambda, right, we have to find eigenvectors corresponding to each value of lambda using the equation A minus lambda Ix is equal to 0. Put the value of lambda, subtract A and lambda I, okay, and then you have to apply your Cramer's rule, selecting first two equations, right? Selecting first two equations. Okay. So I hope you have understood throughout the session. Thank you for watching.